We have already completed our first section of amplitude modulation. The second section is frequency or angle modulation. So angle modulation is of two types: frequency modulation, phase modulation. Frequency modulation is abbreviated as FM and phase modulation as PM. Cumulatively, both are known as angle modulation. So if we have frequency modulation, so it means that frequency of the carrier varies in accordance to the modulating signal. And if we have PM modulation, then the phase of the carrier varies in accordance to the modulating signal. So we know that we have a carrier Ct that is equals to AC cos omega Ct plus phi. So that is a combination of frequency and then phase. We can represent that signal in this format as well, like AC cos omega AC cos theta t. So this is known as angle modulation. And we know the modulating signal is m of t, and the instantaneous frequency is the function of the modulating signal. So what is the instantaneous frequency? Instantaneous frequency is equals to omega c plus the modulating signal if the sensitivity of the modulator is equals to 1. And the instantaneous phase is the integral of the instantaneous frequency. Phi of it is equals to the integral of the omega it. But suppose if your sensitivity of the modulator is not equal to 1, then in that case your instantaneous frequency is equals to omega c plus kf m of t, and the instantaneous phase is the integral of the instantaneous frequency. So if we insert this equation in that integral, so then we can write that equation of omega it is equals to omega c plus kf m of t, and the omega c is constant, so the integral of the constant is t, so omega ct plus kf is also constant, and the integral of the modulating signal mt and dt. So if we have a frequency modulation, in that case this modulated signal is AC cos phi of it, and phi of it is equals to omega c plus k of f and integral of the message signal, like you are inserting here in case of phi of it. So you can see that angle changes with respect to the modulating signal. But if we have a message PM, then we can write AC cos omega ct and then the message signal. So it means that we have a relationship between FM and PM. So like we can generate frequency modulation using phase modulator, or we can generate phase modulation using the frequency modulation, like generation of the FM using PM. So how is it possible? Like you are taking the message signal, passing your message signal through the integrator, and then you will have AT, where AT is the integral of the message signal, and then pass that through the phase modulator, so with that carrier. So that is the FM signal. So FM signal is AC cos, and the angle of that is omega ct, and then kf is the sensitivity of the modulator and integral of the message signal. Similarly, you can generate phase modulation with the FM. So that is the message signal, pass that message signal through the differentiator, and then take that differentiator through the input of the FM signal with AC cos omega ct, and then you will have the phase modulated signal AC cos omega ct plus k, and the integral, you know that the FM is the basically integrating the signal whatever it has its input. So integral of differentiation of m of t, so that will be cancelled, and you have remaining AC cos omega ct plus kp m of t, where kp is the sensitivity of the modulator. So if we want to represent in terms of waveforms, suppose we have the modulating signal m of t whose amplitude is plus am and minus am. So here you don't have any signal, so and here you have positive signal, and here you have a negative signal. So that is your carrier with amplitude of the carrier is plus a and minus a, and this is your FM signal. So this is your FM signal. So you can see that here the frequency deviation is 0, like frequency deviation at this position is 0, so you can see it's a 0 frequency deviation, nothing is going to be changed. But here you can see it's a the frequency deviation is positive. So positive magnitude, you can say that the deviation is positive. If the negative magnitude, you can say that the deviation is negative. So the amplitude of the carrier remains constant. But what about the FM? You can say that if the deviation is positive, then we are having high frequency. But if the deviation is negative, so you can see that the frequency is very low frequency signal. So you can see the frequency is going to be expanded, but here the signal is going to be contracted. So the frequency is very high and the frequency is low. So suppose if we have a square wave, so square wave is something like this, and then same carrier signal. So then what is the FM signal in that case? So here you have a positive frequency deviation. Positive magnitude means positive frequency deviation. If you have a positive frequency deviation, means you are increasing the frequency like this. So Fc plus del F. So if the negative amplitude means negative deviation, so you can see that your frequency is the signal is expanding. So it means that a low frequency. So Fc plus del F, and then in that case Fc minus del F, and so on. So that's it, the angle modulation and the frequency modulation. So I hope that you understand the concept of the FM and PM. But if you still have any question, you are most welcome. You can ask question in the comment box. We will try our best to answer the questions. Thank you for watching the video.